of language processing system is you start with a preprocessor and then we try to either compile it or interpret it. And based on the output, either we use an assembler, which is optional. And the last one is we go ahead with loader or and linker. So this is how things works on. But what really is preprocessor? Preprocessor does some job and converts it into an equivalent high-level language program in order to ensure that your programming work is without errors. Many a times we use expansions, we use more of numerical values, wherein we try to understand here and there a typo errors come in, and the whole output gets different. So to avoid it, earlier days we had macroprocessor. We also had preprocessors for expanding the SQL statements. Those preprocessors came into picture, try to understand or retrieve the required queries, the local data set, so on and so forth. So all these were different kind of preprocessor. We'll try to understand Lex. Lex program also compiles it and converts it into some form where C program can understand. So there are a lot of preprocessors as such. But the main one which we'll discuss on is the macroprocessor. So we'll try to understand how a macroprocessor works, what are the different macroprocessor directives, what are the data structures they are using, so on and so forth. We mainly concentrate on two different type of macros. One is with respect to the assembly language program, and the other one is with respect to the C programming language. So at first, we'll go ahead with the assembly language program, try to understand how the algorithm works, try to understand the different type of parameter substitution, and then we'll move on with the C program. Okay, so the way of understanding it, it is just a shorthand version. In case, for example, you use a swap function. Instead of repeating it multiple times, we define a function. Now, what is the difference between a normal function, procedure, or a subroutine in general and a macro? When you say start executing a program, and when you have a function call, the next instruction which will be executed is the instruction what is the first instruction of the function call. Now, normally while compiling, you don't expand the function call with the set of statements. For example, you have a swap function and you have a swap function call. Before compiling or during compilation, the program doesn't expand the swap function call with the list of 3 statements what you have inside the swap function. Rather, the execution pointer points to the instruction which is located in that particular function. But then what happens to a macro is, while you do a pre-processing, this swap function becomes an inline set of statements. So whenever you have swap as a macro, instead of instead of the macro call, you expand it. And instead of the swap function, you will have the 3 statements where you do the swapping. Fine. So this, they call it the macro processor. What we use, the definition of how you define macro, use macro, you call it as macro programming. And the macro processor or the preprocessor which tries to expand the macros, what we define is called as the macro processor. And therefore, the macro processor replaces the macro invocation or the macro call with the required statements. So this happens during your pre-processing itself. Now, what are we going to learn? How do I replace it? What data structures are required? And so on and so forth is what we are going to learn in the coming slides. So the various phases of a macro processor. You try to give the source code as input. where the macro is defined. And then comes the macroprocessor. This macroprocessor does four functions in it. The first one is it tries to recognize the macro definition. Okay. And then it tries to save the macro definition because it has to store it somewhere. And the next one, this is about the macro definition. You have two things in it. When you have a program with a macro, you have two things. One is the macro definition, the other one is the macro call. So the macro processor's first job is to identify the various macro definitions what we have defined in the program, then save those definitions accordingly. And the next one is, as and when we process, you try to recognize the macro calls and replace it accordingly. That is what they call it as expanding the macro calls. So the output of a macro processor will be the expanded code in a high level language, which is either given to a compiler or an assembler. Now, the various techniques what we use here are copy code, parameter substitution, conditional macro expansion, and so on and so forth. We'll come back to it. Now we'll just take an example of the macro. In an high-level language, in an assembly language, we use macro as a keyword. Okay, so you have the macro here, you have defined a macro, which you call it as strg. Okay, this string is defined as a macro. So strg is the name of the macro. We'll call it as mn, which is the macro name. Okay, and this macro has three instructions to it. The first one is the data 1 is stored onto the accumulator, data 2 is stored onto register A, data 2 is stored onto register B, and data 3 is stored onto another register. Now here ends the macro. So I have two terminologies which I have to understand. To define a macro in an assembly language program, a keyword called as macro has to be used, before which you have a word which is the name of the macro. So strg is a macro with the following set of instructions. The following set of instructions, you have three instructions. Now, where will I end the macro? I can ensure that I end the macro by using mend instruction. So now we'll map it with this one. What happens? You have to recognize the macro definition. How do I recognize the macro definition? I recognize the macro definition with the keyword termed as macro. How do I identify the end of the macro definition? With the keyword termed as mend. And then this has to be stored accordingly. It has to be stored in a data set. So I have to store two informations. One is I have to store in the name of the macro and also the definition of the macro. We have some more information to be stored in. We'll come back to it. So now we'll move on to the next phase, which is a macro expansion, for which I have to identify the macro call. So the macro call, you will have just the macro name alone. So I have used the macro name strg here. Now what happens? This strg single line will be expanded by the macro body. This is what you call it as the macro body, the three instructions. So instead of strg, we'll replace it by the three instructions. Similarly, you have another call here where I'll replace it by the three instructions. Fine. So this is what you call it as the macro expansion. So what have we done it? We'll divide the macro processing into two. One is we'll try to recognize the macro definition, and the other one is we'll try to expand the macro call. But trying to identify the macro definition, we'll know to recognize the macro with the help of the keyword macro. At the end of the macro, we'll define it using mn, and you can store the macro body somewhere in a different data structure, which you call it as the define tab. We'll see that later on. And then you have the macro call. One second. And then we'll try to have the macro call where you try to expand it. So what is the difference between a macro or a subroutine or a procedure or a function, whichever you call it as? The statement of expansion is generated each time the macro is invoked. So you give it to a preprocessor, it expands all the macro calls before compilation itself, before it is given to compilation itself. Whereas subroutine or the function or the procedure, the statement appears only one. Only thing is the control moves to the first statement of the function or the subroutine or the procedure during its call, whereas a macro call is expanded long before you do all this execution process. Now the next one is you have something called as a parameter substitution. Why do I need a parameter substitution? The first example what we saw, there was no parameter to be substituted, which means in the macro you are not passing in any arguments inside. Now the question is, what if I have to pass some arguments? That you call it as parameter substitution. And what happens if there is a variation in the passing of arguments? So that is what we are going to see next. So you have parameter substitution, wherein what are we supposed to do? We'll add one part alone. In the previous case, what I did is you are directly giving it as data 1, data 2, data 3. Every time it refers to that particular memory location and loads it onto the corresponding registers. So how many number of times I'm going to call? I'll take it only from the given memory location and store it onto the register. But what happens in the first time? I have to pass in a different data. Second time when I call, I am supposed to pass in a different data. And therefore, you go in for the parameter substitution. So you have it as you are passing 3 parameters. So you have the normal process, the name of the macro. It is defined as macro and followed by 3 parameters what you pass in with an ampersand symbol appended before it or prefixed before it. So you have ampersand A1, A2 and A3. Now in general, I'll say the location. Storing the first argument to the register A, second one to register B, and third one to register X. Now what happens? The first call, you are passing in 3 different data. We'll take it as data 1, data 2, and data 3. In the second one, you take it with data 4, 5, and 6. What happens? First time you are calling the strg with a different set of data. And the second time you can call the same function, same macro with another set of data. Fine. So the expansion happens accordingly. The first parameter is mapped to the first one. Second parameter is mapped to the second one because we are using ampersand A2 here. And the third one is mapped with wherever I am using ampersand A3. Fine. Now you have a variation here. What happens is, this time it's purely based on how you position it. So the first one is the positional argument. The first one, data 1. Okay, data 1 will be mapped with the first argument, and the second one will be mapped with the second, and the third one will be mapped with the third. Only variation is will be if I'm using ampersand 2 here and ampersand 1 here, 2 will be mapped with the first one and 1 will be mapped with the second one. Now what happens here is we go in for an positional argument where I say, now my definition of your macro is the same, but when I call here, I define certain informations saying that ampersand A3 will be equal to data 1, ampersand A2 will be equal to data 2, and ampersand A1 will be equal to data 3. Now what happens when you call, if I'm giving that information, this data for 6 will be considered as the first one, and then this one will be considered as the second, and this one will be considered as the third. Fine. So that is why you have the keyword argument. Normally, this information is based on direct addressing mode and the different channels what you use it. For us, more important is the parameter substitution. Now, if at all parameter substitution is asked, what we'll define is we'll define three types of parameter substitutions. The one is with no parameter. The first example which we saw is with no parameter. And the second parameter which we saw is with a set of parameters and with the positional, it maps according to the position of the argument what you pass in. And the third one is I can always change the order of the position based on tagging this value with the data value what you have. Okay, because they do give this information. So I can always map it and send the information. Now, you have a term called as one pass macroprocessor. Now, what does this pass means? You have to read the complete program in order to process it. Now, the question is, how many times do I have to read the entire program to process it? So, any translator as such, it has to go through the input program for processing it. Since all your language translators, the input is programmed in some programming language, either high level or low level, the translator has to read the complete entire program from starting from the leftmost character to the rightmost character at the end. Now, the number of times you scan the program, that is, you read the program, is called as an pass. Okay. Now, if it is a one pass macroprocessor, you do the complete translation by reading the input program once. And if it is a two pass macroprocessor, you do the complete translation by reading the the program twice. So you go in for one pass macroprocessor where you read the entire program once and do the required processing. Fine. Now we have to map it with the algorithm. But before we map it with the algorithm, let me talk about the data structures what we use. What are the data structures what we are using in order to process the macros? The first one is the name tab. I told you have to store in the macro definition as well as the macro names. So this name tab is a data structure which stores the name of the macro. Okay, the name tab is a data structure which stores the name of the macro. Then define tab is a data structure which stores the macro body or the set of statements within the macro. Okay, define tab is a data structure which stores in the instructions which you have defined inside the macro, which you either call it as the macro body, all the statements within the macro. And the argument tab stores in all the required parameters which has to be passed. Fine. So argument tab is mostly used during the expansion, and then the macro tab, define process is takes care of the name tab and the define tab. Okay. So in the algorithms, what we are going to see will have three main functions. One is the process line. You try to process every line in your program. And then if it is a macro, we go in for the define process. If it is for an macro call, you go in for the expand process. Now, before we move on to the algorithms, we'll have few polls so that we'll try to understand what we have seen so far. Okay. You have a question which you can answer to it. There are only 7 people. Hope they have answered. $28. I'll hold on for a few more seconds. Okay, let me end the poll. Thank you for answering. The macro name is stored in the name tab, not the define tab. And there are few who have taken it as name table. The data structure name is NAMTAB. And therefore, half of you have got it right. And the other has gone for define tab and name table, which is wrong. Okay, we'll have one more and then we'll move ahead. $32 have answered. We'll wait for a few more seconds before I close it off. I'll close it off. I'll end the poll. You should never ever map the keyword. Sometimes it doesn't work. And here you have, most of you have mapped pass with passing parameters of to the macro. I purposefully added this passing here. Pass means scanning the input program. If it is one pass, you try to scan the input program one time before you convert it into the required output. If it is two pass, you can read the program twice before you convert it into a given output and so on. So pass is the number of times the input program is scanned before you try to convert it into the required format. Fine. Now let's go ahead with the algorithms. Okay, we'll start with the begin part. Now, expanding has to be false because you have to check whether you are reading line by line. Okay. So, for example, if I can take this particular part alone and paste it, let me check. Okay. Now you start with the macroprocessor processing as such. So you start with the first line. We make expanding to be false because we haven't encountered the uh, macro yet. So we have defined expanding is a Boolean variable where you say the processing is false. And then you have to check for the opcode m end. Here they have taken it as end. We'll check for the opcode m end. Till the opcode you have reached, you have to do something. Sorry, we'll talk about this opcode end, not the m end, but then the end of your assembly language program will be represented by an keyword end. So till you read the end keyword. Why do I do it? This macroprocessor algorithm is written for an assembly language program. So if till you reach the last instruction of your assembly language program, you are supposed to repeat the processing. And what is the last statement of the assembly language program? The last statement of the assembly language program is the instruction end. So till the opcode is not equal to n, we are iterating the others next set of process. And the first one is an getLine function. Now we'll check what getLine does. Okay. GetLine performs two things. One is if expanding is true, it has to perform something. But as of now, our expanding is false. So we'll just check the else part alone. Okay, your expanding is false and therefore it will do the else part alone. So else part, you read the next line from the input file and give it to the next function. So we have, since expanding is false, we have read the next line from the input file and we are giving it to the process line function. Fine. Now what happens? So it comes over here. What happens for the process line? It begins to search the name tab for the opcode. If found, you are supposed to expand it. Okay, you are processing it. So now what am I supposed to do? I am supposed to expand it. So now if you try to, whenever you process it, you try to identify the name tab. Okay. And now, so if when I have strg to be read, I'll check for the opcode. If the opcode is there in the name tab, which means I have already stored strg in the name tab, I'll say expand. Expand is another function call. But if the opcode is macro, which means I'm going to define it now. In that case, you call and define function. If you just look at here, in the previous slide, you have a macro process line has two calls. One is define and the other one is expand. When there's a macro call, you expand it. When there's a macro definition, you define it. So if the opcode is macro, then we are supposed to define. Else, there are three parts in your program. One is the macro body, other one is the macro call, and the last one is the other set of instructions what you have in the assembly language program. So if you have any other instructions other than the macro body and the macro call, you just write it on to the output slide. Okay. Now we'll do it one by one. If the first one is, we'll define this macro. Okay, we have to store it somewhere, and for which I have to define it. So I'll use two things. One is I store the macro name into the name tab. So you have a name tab. What will I store in? I'll store in strg. Okay. And onto the define tab, what should I store in? I should enter macro type into define tab, and then I have to store in all these informations. STA data 1, STB data 2, STX data 3. Okay. Now, can I allow nested macros? Nested macros is also allowed, and therefore we'll assign it to level 1. The first macro, what you read, we'll assign it to level 1. When level is greater than 0, you're supposed to get the next line. Check if it's not in command line. Check for positional parameters. Those parameters we'll enter into the define tab. And if you have another macro definition within the given macro, we'll increment the level 1. If it is macro m end, we'll reduce it. So what happens in this case? When it reaches the macro, the level value is set to 1. Okay, and then all these are stored onto the define tab. For example, okay, for example, one second. For example, in between the these two slides, these three statements, or before after the third statement, I have something called as ABC macro. What has happened? Now I have something called as a nested macro. So if I have this, when it comes to this point, the level becomes 2. Okay, and that is what is set here. Where is it? Yeah, that is what is set here. You do it normally, you read the parameters, you put it onto the define tab, but then there can be two options. You can have a nested macro or you have an m end. So if the nested macro comes in, you increment the level to 1 because you are saying there is a nested macro. Illa abdina, if you have m end, you decrement the level and just come out and store the name tab pointers to the beginning. You store it relevantly. Okay. So this is how you define it. And then, so this part is done. What happens if opcode is macro? But then if I have found the opcode in the name tab, what am I supposed to do? I am supposed to expand, or you have to perform an expansion. So now we make expand to be true. So far, my expanding was false because I'm not expanding the macro calls. So my expanding was false. But now I have made the expansion to be true. Get the first line of macro definition from the define tab. So you have to read every line from the define tab. You have to map according to the arguments, and then store it on to the output file. Now, till you go ahead with the end of macro definition, this goes on repeatedly. Once you have expanded completely, we'll say expand is equal to false. Fine, we have already talked about get the definition. Now we'll come on to this stage. You have get line, you have process line. When it comes to get line, we haven't touched this part yet. The first part, if the expanding was false, we'll just read the input. But what happens in your get line when is expanding is true? That is when you expand a macro call. You just go ahead, try to get the next line from the define tab. If the expanding is false, you are supposed to get the next line from the input file. Whereas if not, you have to do it here. Okay, and substitute the arguments accordingly and then store it. Fine. So this is how it works. Can we take a small example and see how it works? Hope after the algorithm will be more clear how to do it. We'll take the same old example with the positional parameter. Okay, let me take this part. Now, what is this? This becomes the source program or the input program. We'll take it as input. Okay, I'll just use only one macro call. Now, when this comes into picture, what happens initially? Initially, the expanding is false. Okay, this is how the processing goes on. What I'll do is I'll also write the output file. Okay, so the expanding is false. Now we'll move on to how the things work. Where are we? Okay, till you have the opcode to be n, the expanding is false, till you have the opcode n, you are supposed to get line, process it. If the opcode is macro, you have to store two informations, the name tab as well as the other tabs. Now we'll see how it works, okay? Okay, now this is false. And then you have a keyword macro. So what am I supposed to do? I am supposed to store this in the name tab. So name tab is a data structure where I'll be storing the keyword, the name of the macro, which is strg. And then comes the define tab. That happens in your get line, define procedure. Your define tab will have the other information. So when I store in all the other information, I'll say these are the arguments what you have, and this is the body of the macro. The body of the macro is given in a different color. Okay. Now what happens? You come to mn. At this particular time, when we are expanding the level will be 1 because you have a macro. And then when it comes to mn, the level becomes 0. If I have nested macro, it goes to 2, 0, 2, 3, and so on. And then it gets reduced accordingly. So this is the level variable what you use. Now comes the macro call. What do? I do an expansion. So between the m end and the macro call, I can have n number of other statements. All those statements, I'll write it onto the output file. So far, since it's a macro, I haven't written anything onto the output file. For example, this is just for an example, okay? I have an add statement where I say add a comma b. Okay, that cannot be done. We'll have an STC statement where I directly store in data 4. Now what happens? This is a macro. Because your expanding is false and you're defining a macro, I haven't touched the output file. Once the macro ends, macro definition ends, the other set of statements in your program will be directly written onto the file, output file. Now, when you have a string, when you write it onto an output file, you have to check two things. If there is three things. If there is a macro definition, do not write it onto the output file, but rather store relevant informations onto name tab and def tab. The next one is if it is a macro call, expand the macro call and write it onto the output file. And the third one is if there is a instruction which is not part of these two, write it onto the output file directly. So now comes a macro call. I have found this strg in the name tab and therefore expanding becomes true. Expanding becomes true. Okay, and what you do here is you have something called as another data structure argument tab where I store all these arguments. And now I expanded, and therefore these set of values instructions are stored onto the output file, where instead of ampersand A1, it is replaced by data 1, ampersand A2 is replaced by data 2, and the last one is replaced by data 3. This is how the expansion happens. Fine. Hope you have understood this part. Can I Can you raise your hands if you have understood it? If not, which part should I repeat? Okay, thank you for your response. So that is what is here. They have given a different example. You can use the example what we have already seen. This is for a nested macro. Okay, this information is not for next nested macro. You have macros. This is what a name of a macro. Macros is a name of the macro. Within that macro, I have two different macros defined. One is read buffer macro and the other one is write buffer macro. So what happens? This is level 1, level 2. The macro n comes. So it becomes again level 2 and then it moves on. Okay, so you have the macro information here. This is all what we have explained. Okay, one pass goes on and on and on because we need all these processes. So this is how your one pass macro works in macroprocessor. Expanding is false. This is just a diagrammatic representation of all the 4 algorithms what you define. Now there can be a single pass macroprocessor and a 2-pass macroprocessor also. In your single pass, identifying the macro definition, identifying the macro call, expanding it happens at a stretch. But then nested macros will not be allowed, may be allowed, but the nested calls are not, which is quite tedious. In a 2-pass algorithm, you will define macros or recognize the macros in the first phase. And when you read the program second time, you recognize the macro calls and expand it. In a 2-pass macro processing algorithm, nested macro definitions are not allowed, whereas it is allowed in a single pass, but it is quite tedious. We'll stop here. In tomorrow's class, next week's class, we'll just take a program as example, C program as example, and try to understand how the macros will be expanded, which will be a part of your system software and programming, system software and compiler lab. If you have any doubts, you can stay back, clarify your doubts, else you can leave. Thank you.